Hey, what's going on, everyone? We're starting our second week, and we have quite a bit of information to cover. So I'm going to try and do this as quickly as possible and still focus on the important points. Excuse me. So this week we're going to be covering some more information on data types and how they're used, and developing a program. So last week we discussed integers and floats a little bit, and this week we talk about character and string data types. And a character is exactly that. It's a variable or a location in memory that can only hold one character, whether that could be a alphanumeric character or a special character or what have you. But it's important to understand that it can only hold one character. And the string variables can hold a number of characters to include spaces. Different programming languages have different limits for their string variables. Some hold up to 255, some hold more, some hold less, and you'll get into that when you get into your higher level languages. Now, it's very important to remember that if you have variables that you declare as a character or a string, you cannot use them in mathematic operations. You're not going to be able to do any kind of math on those, and certainly not in this class. Now, later on, when you move into C++, you'll be able to do some kind of ASCII mathematics, but that's pretty that's beyond the scope of this class. Um, Now we've already seen in the text the declare statement and how that's used. So it's very important to remember that before any variable is used, regardless of the data type, it has to be declared in the program. And now most data types are declared in main. There are a few exceptions for that, and I'll get into that in just a few minutes. But as I said last week, all variable names must have a meaning, and the variable name itself cannot contain spaces. So if you look at this, the couple of bullets I have down there, this is the syntax we're going to be using. Declare variable name as the data type. So the example is declare count var as integer. And so that middle line would be correct rather than doing declare count space var as integer. So that last line is going to try and do is create two variables, one named count and one named var, and that's obviously not what we want. Integers, of course, are whole numbers to include negative numbers and zero. So it could be a negative 14 is an integer, a 27 is an integer, and 0 is an integer. These are simple values and consume very little space in memory, which is going to be important as we move forward and start focusing on the efficiency of our code and making sure that we declare variables the right way and make sure that we're not just declaring everything as a float, regardless of its need. So, but as we do that, if we're declaring variables as integers, we need to be careful in arithmetic operations because if you use two integers in a division operation, it's very likely that the result of that is going to be a float. So you need to make sure that you have a variable set aside or a variable declared for that to hold that particular result. So and then floating points are numbers with fractional parts. Of course, floats take up more space in memory, and again that it's dependent on the language that you use that determines the specific amount of space that each variable is going to use. And of course, it also depends on the length of the fractional part. One important note, the integer representation and types of floating point numbers are not covered in this text. Now it is explained in the text, but it is beyond the scope of the course, I should say. We've been asked to not include that in the lecture. But I'll definitely recommend that you at least become familiar with that, because as you move on to your higher level languages, that information is going to be very important. So the text also talks about using binary numbers, and as we talked about before, the true machine language is ones and zeros, or a binary number. So, and the binary number is a base 2, which is a 1 or 0, and then decimal is a base 10, that's 0 through 9, and then we also have octal, that's 0 through 7, and hex, that's 0 through F, or 15, that's also used in some code. We're not going to get too much into that in this course. But I want to show you a real quick way. This is a really easy way to convert a binary number into decimal. So if you look at this, this is really a 9-bit representation, but the typical representation is 8-bit. So if we have an 8-bit number that's 00101100, all you have to do is put your binary number under this chart, and under each block that has a 1 under it, you take that number and add them up, and that gives you the decimal number. So a decimal 00101100 is the equivalent of a decimal 44. It's just that easy. So we're getting back into the program development cycle, or the PDC. So page 71 of the text talks about analyzing the problem. So later on in later assignments, you'll be required to include your analysis of the problem, as well as the design of the problem. Now the analysis is very, very important. You want to make sure that you define all the details that are in that problem, and define clearly what the expected input is going to be, what the process on that input is going to be, and then what the desired output is going to be. So and then when we get into the later steps, we can test that to test the output of that to determine whether it reached those objectives. And we'll also talk about the design of a program on page 72. And now, again, in your assignments, when we start doing the design phase of this is the portion that will actually contain your pseudocode. And within the pseudocode, now of course it's going to contain more than pseudocode, and it's very important that you read through that information on page 72 to determine precisely what's going to be needed in that. But your pseudocode will be a step-by-step method to solve the problem that was identified in the analysis phase. And the final result should be a well-designed and well-ordered product that's easy to read, and we'll talk about that a little further later on. So the next step, of course, is to code the program, and that's to convert your pseudocode that you created in the design phase into a language of a specific programming language like Java or C++. And now the text only talks about adding documentation or comments in the code as you're actually writing your programming language. However, for this class, it's very, very important that we get into the habit of documenting our code as we're writing it. So we're going to be commenting our pseudocode as we develop it, and that's going to be for every assignment that you turn in. I really want to see as much comments or documentation on that code as possible to explain what's going on in your code. And of course, the final step is to test the program and to determine whether that output met the criteria of the analysis phase, and to whether it met those needs. So there's also in part of that PDC. Of course, when you write a program, you're not just going to do the analysis, do the design, write the code, and test, and then that's it. Of course, after testing, there's in most cases you'll need to go back and touch some of that code again to make sure that it does indeed meet the requirements of the code. Now that's part of the cyclic process that we talk about here. But also, and this happens very often, as time goes on, the the requirements of that code changes. So in other words, the organization that you're writing the code for may need the code to do something else, or they may not need it to do a certain aspect of that code any longer. So you'll need to go back and change that code according to those new requirements. So this is also very important, and it's pretty critical that we get our brains wrapped around this early on. Modular programming is exactly that. We have in our design, we're going to have a main module, and every code that we write is going to have the first line of that code is going to be main module, and then you're going to have the variable definitions and the function calls if we have them, and then you're going to have the end program to end that main module. Um, so so in that modular design, so it's very important as we do the analysis, we determine what each major task is that we need to accomplish, and we separate those major tasks into modules underneath the main module. So those are going to be modules that we call from main, and we'll see that here in a few minutes. But so this is done for a lot of reasons, but one primary reason is if you decide to get into program development or software development rather, you'll see that different teams are assigned different parts of the program. So and that one team might be assigned one module. So as one team produces the main module, they'll call the sub module, and that'll be your module, and then you need to provide the desired results to return back to main. So one other cool thing about the modular program design is that you can reuse code, and actually when you write code, you can put that code into libraries and reuse that code over and over again in other programs, and you don't have to keep reinventing the wheel. And I actually do that quite a bit with PowerShell and some other applications. Of course, pseudocode uses short English-like phrases that kind of look like code. Our pseudocode programs will eventually look a lot like code. And the syntax that we use for our pseudocode will be specifically out of this text. So I know that there are several people in the class that have had some exposure to C++ and Java and PowerShell and some other sources, but I need everyone to have code that is very similar. So we're going to use the syntax that's in the text, and so I don't need any include statements in any code or anything like that. So if we look at the evolution of the module in example 2.5, you'll see that that the coder started with a very general general few lines that accomplishes what he needs to accomplish, and then he's added a few lines more and a few lines more until he got exactly what he needed over there on page 81, about midway through. And again, now it's important to understand that this is a module in the program outside of main. So we will have a call statement that calls this submodule, and it will do whatever it needs to do, and then maybe return a value back to main, or change values in variables based on what is needed later on in other submodules. So that being said, every program that we write will begin with a main module. And the main module will contain most of the variable declarations that we use throughout a program. and all submodules are called from main. It's very very rare that you will ever need to call a submodule from another submodule. That almost never happens. Um, and we'll see in a few minutes that when when a submodule is called from the main module, it goes out to the submodule and does what it needs to do, and then comes back to the same spot, and then executes the next line in the main module. So let's take a look at that real quick, and we'll see how that works. Okay, so this is the code in example 2.6 on page 83 of your text. Now I've changed this just a little bit, and I'll show you why here in a few minutes. But you'll notice that each variable declaration is taken care of in the main module. There's one other variable declaration that takes care elsewhere, but we'll see that in a minute. And then this write statement sends lines out to the display to give instruction or information rather to the user. So at this point, this call input data module, when this is called, it goes down here to input data module, and it of course it writes what is the item's name. Now again, this is a little different than what's in the text because I believe I mentioned last week it's very important to visualize what the user is going to see and to make sure that the information given to the user is very very clear on what they need to do. So now in the text it has it writes what is the price and percentage discount. Now I've actually separated this. Let's look at this first. So what is item name? This you enter the item name that's being analyzed, and then I've separated this into two lines. I have the first line is what is the price of the item, and have the user enter the original price, and then I have another line that asks for the discount percentage of the item, and then the user inputs the discount rate. And of course, all of this information is going into variables that was previously declared up here in the main module. So once that module is complete, it goes back up here to the second call. So it calls call perform calculations module. So it goes down here to this line, or to this module rather. And now you'll notice that there is a declaration statement for another float variable called amount saved, and I'll show you in just a second why they're doing this. So amount saved is the local value, and it's going to multiply original price times the discount rate divided by 100, and place that in the amount saved, which was declared here in the module. So then sell price, which is defined in main, will contain the value of the original price minus amount saved. So that's all that amount saved variable. That's all that does. It's only used in that submodule, so it's okay to declare that module. I'm sorry, that variable there. Now we'll discuss later on the difference between global variables and local variables. The variables up here that are declared in the main module are effectively global modules, and that global variables rather, and so that means that the modules can see those variables in every module, where this is a local variable and it can only be seen while this module is in execution. So once it calculates the sale price by subtracting amount saved from original price, and then it calculates tax by multiplying sale price times 0.065, and calculates total price by adding sale price plus tax. And then when it leaves this module, when it goes back up here to this line, this variable of amount saved completely disappears. It's erased from memory. That memory location is freed up again to be used by some other variable. But once this module, perform calculations module, is complete, it goes up back up here to call the last module, which is results, output results. So then it just basically displays out the results of all those calculations to the user. Now you'll notice that when you are displaying information out to the user, you need to be very careful about how that information is going to be displayed, to make sure that if you have some string and then the variable going out, you need to make sure that there's a space in there. All this stuff is going to be jammed up. So you notice that they have a space on each of these lines to separate the text that's being printed and the variable. And then once it finishes that last line, it goes back over to the top and in program, and that's it. Okay, I mentioned earlier that the text really has you start documenting or commenting code when you start to transition your code from a pseudocode in the design step to the coding step when you're actually writing that code into the native language. And I mentioned that it's very important to get into the habit of commenting that code. So I'm going to ask that you use code on every bit of information, or every code that you write for me. So if you look at examples 2.7 and 2.8, that gives you an idea of how this is going to be done. Now, the example on 2.7 is pretty good, and you can do it that way. You can put the forward slash, the double forward slash in there twice if you want. But you can also do it a different way, as you saw in the code that I wrote. So you can also use a forward slash splat and enclose all of that, and you can do line after line after line, and then put that asterisk forward slash at the very end, and that's going to be the same thing. So now the text also talks about external documentation, to include the guidance for the code and all that. I'm not too concerned about that in the class right now. My primary concern is to introduce to you guys how to begin writing the code, and get a good idea of how that code is put together before you start moving on to your higher level languages. So real quick, we talked about the different data types: character, string, integer, and float, and how each of those is used. And one of the most important things to remember is that characters and strings can't be used in mathematical operations. Also, a character can only hold a single character of data, whether it's a number or a character or a special character. Integers and floats, of course, are of a numeric value. Integers being whole numbers and floats being of some fractional value. Again, it's also important to remember when you're doing those arithmetic operations to make sure that you have the right variable, the right data type to hold that product. So we talked for a few minutes on binary numbers. There's a lot of information out on YouTube and other sources on how to detailed information on converting decimal to binary and binary to decimal, and hex to the different numbering sequences. I'm not too worried about that. You'll certainly get into that later on when you start getting into your higher level languages. And of course, we also talked about the program development cycle again, and we talked about the standard PDC as well as the cyclic PDC, where you write the program and then you have to go back and test or modify the code based on the user's needs. And we talked about modular programming. Now, the first assignment really doesn't specify the requirement for a modular program. However, as I mentioned before, every program that we write is going to begin the very first line, aside from your comments, is going to be main module, and then the declaration of the variables, whatever module calls that you have beneath that, and then in program is going to be the last line under the main module. We talked about the modular design and how those the major tasks that you identified in the analysis are effectively going to be your modules underneath the main module. And we talked about pseudocode, and all of our code is going to be the syntax specifically specified in our text, and we're not going to use any other code in our documentation. And also commenting our code to make sure that everything is identified and explained as what's happening in your code. And the reason we do that, by the way, is because I can't tell you how many times I've gotten my hands on a program and there's not a single line of documentation in there, and I have to reverse engineer what this coder has done, and that just takes far longer than it really is required. So that's about it for this week. If I miss anything, please let me know. I'm sure that there's some details in there that I might not have gotten all the information for that you might need. So if so, let me know, and I'll be happy to cover that for you. You guys have a good week and good luck on assignment 1.